Before we look at what is written here, let us go back to our subtraction rule. Remember, we have a to the m divided by a to the n, and we had an answer of a to the m minus n. We already considered m larger than n. We considered m equal to n. Remember, then we arrived at a to the 0 equal to 1, where a is not 0. Now let us look at m less than n. First, let me show you an example. Like, for instance, suppose we have 3 squared divided by 3 cubed. That will give me 3 times 3 divided by 3 times 3 times 3. If I now simplify, I will get the answer of 1 over 3. I will get the answer of 1 over 3, and if I use the rule, I will get 3 to the power of 2 minus 3, which is equal to 3 to the minus 1. Again, remember we said we cannot have two different answers or arrive at a different answer when we use a different method. It should be exactly the same. So let us change the color again and then look at what we have here. So the rule just says that if I have a negative exponent there, then I can write it as 1 over a to the n. And vice versa, if I have a to the 1 over a to the n, I can write it as a to the minus n, like there. So remember, the equal sign goes both ways. So let us look at, for instance, how can I now combine this in a more intricate. Let me just see here, the minus 1 does not show here. The minus 1 does not show there. Okay, so we must, it is like the a to the 0. It's just a convention that if we arrive at a negative exponent, we can always write it as 1 over. And vice versa, if the negative was below there, then if we have 1 over 3 to the minus 2, then we can also write it as 3 squared. It doesn't matter where the minus is, so we can say, okay, you take it over the division line. So from bottom we go to top, or in this case from top. Remember that we can write that as over 1, and then it means I take the negative in and I make it positive there. But it just comes from this subtraction rule. It's exactly the same rule. It's not a new rule. It's just this situation where we have m less than n. And that is how simple it is. So, again, you must remember the convention. It's like a to the 0 equal to 0. It's just a result of this subtraction rule. Let us now look at this example. If I just go by my regular ways of solving this, then I will say, but on top I have a 3, I have 2 x's, I have 3 y's. At the bottom I have 3 times 3, I have 3 x's and 2 y's. So I can cancel the 2 y's, I can cancel 2 of the x's, and I can cancel the 3, so I get 1 in the numerator and I get 3x in the denominator. And there's also a y there. So our final answer is y over 3x. if I use my rules for exponents, then I can write the 9 as 3 squared. So have 3 to the power of 1. I'm just going to write it there as a reminder that it also has an exponent. X to the 3 y squared. So if I now use my exponent laws, I will get 3 to the power of 1 minus 2, that's the subtraction rule, times x to the 2 minus 3 times y to the 3 minus 2. Like that. So that gives me 3 to the minus 1, x to the minus 1, y to the 1. And I don't want to use negative exponents, so everything that's negative, I will remember this is still, even if it doesn't say so, it's still on 1. So the y to the power of 1, I leave it in the numerator. The other ones, the 3 and the x, goes to the denominator, which is much quicker than before. If you want to, you can also do the subtraction. You can take that 2 down there, you can say x to 3 minus 2, and you can take that up, and you can take that one down. But in general, I will write down whatever is in the numerator, and I will subtract whatever is in the denominator, and then I will rewrite it so that I have all the negative exponents shifted to the denominator, or the numerator, whatever case it is.